And now, I was a bit disappointed because Galina didn't ask for more data during her presentation. But sorry, Galina, here we come with more data from the Geminids. The first speaker about the Geminids is Bernd Gährken. He's going to talk about his observations in southern Spain last year, Geminids 2023. So, Bernd,
I do approve.
Have the time, the countdown here. It's starting now. That's the time that you have, and there will be still a minute for questions.
Thank you very much. A few minutes ago, we heard from Jürgen Rendel that the most popular shower in the year are the Perseids, but the biggest shower in the year are the Geminids. And the Geminids are not so popular for a simple reason, because in Germany in December the weather is cold, the weather is bad, it's there a lot of rain, and the people don't like to go outside at these conditions. And the conditions maybe in other countries better. And we have a look to Spain today. The reason for the speech was not the Geminids at the beginning. It was the occultation of the star Betelgeuse by the minor planet Leona. That was at 12th December last year. And that was only 2 days away from the Geminid maximum. So it was interesting to combine both events in a few days. And so we have a look also to this big event, which is one in a lifetime event. We know very much about Betelgeuse, we think, and about Leona from eclipsing by stars. We know the diameter, and this was the prediction. The minor planet should be as big as the star, and there was a question: will there be a total eclipse or only an annular eclipse? And it was a big surprise to see the result. We can talk about it because some people call this a minor planet. I call it a big meteor in orbit. So it's possible to have a look. This is a video in real time made with a little telescope and a spectral grid. And it was with low resolution to get more light in the grid. We check the colors with this method. And now we can see in real time the occultation of Betelgeuse. We have a few seconds at the beginning. Higher, okay. So somewhere in the middle of the video, it should become decrease. Skid and up and down. We repeat it because it's so nice. And that's real time. We have also seen it with the naked eye. It was a light reduction, so about 2 magnitudes. So a quarter of the light was still visible. So it was an annular eclipse because we stand near the center line. And one more, please. And there were some unexpected results. For example, it was a longer eclipse than expected. The expected time was only less than 10 seconds, and in reality, we have seen an eclipse with more than 13 seconds. And before the occultation, we know the diameter of Leona by the eclipsing of different stars in the past. And so the result shows that Betelgeuse must be bigger. We also can make Leona a little bit bigger, but it was an annular eclipse, so Betelgeuse must be always bigger than Leona. And this is the result. This is the time we have seen. It's more than 18% longer than expected, but we know it cannot be Leona, the bigger one. Yes, both Leona and Betelgeuse together are the time, the expected time, but this was the reality, this error. And at the moment, it looks like Betelgeuse must be 30% bigger than expected. And that's really uncommon, and it's still in the discussion in the science. Yes, but back to the Geminids. Why is it interesting to go to southern Spain for the Geminids? One reason is the cheap flights. All these yellow dots, the big dots, show a connection with Ryanair. Yes, also here from Prague, it's possible to go to Malaga, in southern Spain, with Ryanair for a low amount. For example, here, yes, with 40 euro for one way. And also it's possible to go back. It's always important, yes, with 40 euro. And so it's interesting for a weekend to go there and to observe meteorites, and maybe also the Geminids. I think also the Perseids interesting in summer, because you have not so much problems with the Starlink satellites. Yes, in the northern areas you have Starlinks during the complete night, but in South Europe it's reduced by 50%. And if you go to the Canary Islands, you see nearly no Starlinks at midnight. Yeah, other advantages are nice temperatures in December. There are also high mountains in southern Spain. There's a really dark sky. That's the reason, because there are big observatories there. There are good weather, yes, and there are touristical highlights, yes, like for example here in Granada, the world famous Alhambra, which is also a World Heritage good, like Gutnaora, yes, and there are many cathedrals and castles, and it was a rich area in the 16th century. It's the beginning of the discovery of America. And also here in southern Spain, there is a desert, the only desert in Europe. And the reason for this desert is here, the desert of Tabernas. Are these mountains? There are mountains in the north, there are mountains in the west, there are mountains in the east, and there are mountains in the south. And that's the reason, because it's so dry at this position. So here is always good weather, or nearly 250 days a year is sunshine. And here are also the testing areas for solar plants, yes, for electricity in this area. And the high mountains in the south here, that's the highest one, are more than 4,000 meters high. And so you have also snow here in the summer. That's the reason, because it's Sierra Nevada, White Mountains. And these White Mountains, the Sierra Nevada, are nearly as high as the Teide. Yes. The highest mountain in Spain is the Teide, but the highest mountain here on the continental Spain is in the Sierra Nevada. And here is Cala Alto, the famous observatory, and it's at 2,000 meters, and that's comparable with La Palma, which is also 2,000 meters high. Unfortunately, southern Spain is very light polluted as a coast. Here can you see it, and here also in Granada. But here in this region, it's very dark, and I can say it's comparable with the Alps. I'm observing very often the Alps, and here Cala Alto is comparable with the Alps. And if you put the words astronomy and Andalusia to Google, you can find many, many observatories which are in this region. Many of amateurs and many of professionals. So you can also visit these observatories, which is interesting during a holiday. The most famous one is certainly here, Cala Alto, with many big telescopes. But there are also many amateur observatories. For example, this one here in Gorafe. There is a dark sky park in this area, and it's founded by the European Union. And so you can observe as an amateur here with these telescopes. And last but not least, there are many, many interesting touristical highlights in this region. Here, every position where this little picture is a cathedral, because it was very rich in the 16th century. And every one picture here is a castle, because here fighted the Christians and the Muslim world. So there are many castles in this area. And there are also Western cities. because in the desert of Tabernas, Sergio Leone produced his Stalo-Western. Yes. There are several ones, and big caves. For example, this cave in Nerja, it's the biggest stalactite in the world. You can see it. These are people here in the background. It's more than 40 meters wide. Great cave. And here you can see again all attractions in this region. B means a castle, K means a cathedral, and the S means something else. So we also like to see some Geminids, and I can say it was very dark in the nights when we observe. In the first night, we see more than 200 meteors. We really tailed this. One person of our team looked every time to the sky and tailed it. More than 200 in the first night, and in the second night, he tailed more than 300. So it was 500 meteors in 2 days. So if you see the relation to the speech of Jürgen Rendel, it's 500 meteors, that's much. And here you can see our weather. Here in the first day, it was not so good, but here the second day and the third day was wonderful. And you can see also the temperatures. This is in the mountains, and in the night here in the mountains, it's 1,300 meters, it's 2 degrees. And if you go in the flat areas in front of the mountains, it's 10 degrees in the night in December, so it's fine. We use the dark sky and the good weather for a comparison of 2 camera systems. This is the Vatek, that's a working horse. It's translatable into English, I don't know it. In Germany, we would say Arbeitspferd. It's a working horse for many years in the astronomical community, and it's no longer in production, but many people today use a Sony 7S, which is very sensitive, and we compare both it. This has an f-stop of 1.2, this optic, and this optic has an f-stop of 1.4, so it's not a big difference in the f-stop. And also the difference in the field is not so big. And the price for the Sony is decreasing during the last years. Sorry. It was more than 1,000 euro some years ago. Now you can get it for a much lower price at eBay. And here you can see the number of the meteors we measured with both systems in 3 hours. In 3 hours, we get every hour 20 meteors with this system. And we get every hour 65 meteors with this system in the first night. It's 3 times more. And here you can see all the meteors in 3 hours made with this system. Common photo lens 50 millimeters at the Sony. It's more than 270. And here you can see a comparison of the Vatek meteors and the Sony meteors in 3 hours. One is 4.2 hours and the other one is 3.5 hours, as you can see in the down right. It's much more here with the Sony. But we have to say the field of view is a little bit bigger with the Sony than with the Vatek. If you compare it exactly, you can see it. This is 50% more. In the second night, there was a difference. Yes, in the first night, there was a relation of 1 to 3.5 between both systems, but in the second night, it was only a relation of 1 to 2. And the reason was simply because in the second night, we have more bright meteors. It's typical for the Geminids that they have, after the maximum, more bright meteors. And the bright meteors are better detectable also with the Vatek system. And so that's the reason, because the relation was better in the second night. You can see all the numbers tailed. And last not least, we have also seen some persistent trains. Some years ago, you can read in the books and in the literature that there produce no persistent trains to Geminids, but they do, as you can see here. And it's interesting, sometimes very bright meteors, very bright Geminids produce no persistent trains. Yes, and sometimes weaker Geminids produce a persistent train. And that's still a little miracle, and maybe the reason is the orientation of the meteor. For example, if this is the meteor and it comes to the atmosphere and it has this orientation, it don't produce much light, but it comes very deep. Yes, and produce in the deep a persistent train. And if the same meteor with the same mass comes with this direction in the atmosphere, it produces much light, but it don't comes very deep. And this maybe could be a reason for this. So, and here we have a last video of one of the brighter meteors. We have not seen much fireballs, but some brighter meteors. And this is one also with a persistent train. You can see it. So if you'd like to see more, you can look on our homepage with this address, astro.de, IMC24, and then you can find more information about Betelgeuse and also about the Geminids in the last year. Thank you very much.
Thank you, Bernd. We have time for questions. Thank you also for the promotion of Spain. I fully agree with everything to what he said, and you are very welcome. It's true that usually weather is good for December and skies are dark. So let me double check. There is no question written and no raised hand in the virtual room. So here in the real world one, is there any question for Bernd? Okay, I have a question for you. You have mentioned the Sony Alpha 7. As I understand, that is like the version number 2. I don't know. You have had a chance to test the version number 3, that I have just heard that it has been released to the market.
I still have here the version number 1. Yes, it's without the Star Eater, which is the problem of the version number 2. And I know nothing about the version number 3, but I think it worked better.
Okay.
Peter?
Yeah, actually, the version, the Mark III has been released, I think, 3 years ago, so it's not new anymore. And I have to say, there's also a professional version that is named differently, but it's the same technology and the same sensor, but it's a professional version, and this is the FX3. And for example, if the next new one will be an FX3.
That's fine.
Looks very differently, like a brick. But one remark to the version, the Mark I. Yes, you can buy it very cheaply now, and that has a reason, because the camera is aging physically also, like we all. And for example, the number of cosmics showed by the camera is increasing with the time. So you should make a calculation if it's worth to do that, and maybe you go better for the version number, the Mark II. But the Mark II is much more expensive because it's more actual. I mean, in German we say, ein Tod muss man sterben.
But we are astronomers and we know how to make darks, so we have not such a big problems with version number 1.
Yeah, but in the video inspection, it's a kind of a problem when you make visual inspection of the outcome. And also, very important, versions number 2 and number 3 are capable of UHD, so let's say 4K resolution with internal recording, but the Mark I is only capable of UHD recording with external recorder. So that makes also a difference.
Thank you very much.
Okay.
More detail if you like.
Thank you. So I don't know if there is any other question. Otherwise, let me check. No. So thank you again. We thank again the speaker.